Welcome back. We are in 12.6 and you are starting with an exploration where you will need scissors and a piece of paper. Do not skip this exploration. Press pause, press play when you're done with the exploration and ready to move on. So now let's look at an animation of that exploration you just did.
First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So, the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius, so height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle.
All right, so that is an animation of the exploration you just did. So as you saw in the exploration and in the animation, that we have area is equal to pi r squared, and you can see where that comes from. So if we have a diameter, let's say we have a diameter, we actually do need to calculate the radius, which is always half the diameter, and then we can just use the formula pi times the radius squared. We can get an exact value or an approximate value. So determine the exact area of a circle with a radius of 5 yards. So we've got our area formula is pi r squared. They say exact, so our answer is going to be in terms of pi, and so our area is going to be pi. They give us a radius of 5 squared, so it's going to be 25 pi square yards because we are talking about area. Here they want to determine the area of a circle, but they want us to use 3.14. So our area is pi r squared, and because they want us to use 3.14, not the pi key, we'll type that into our calculator. I just happen to know 3 squared is 9. And we end up getting 28.26. Always make sure to include the units. These are square feet. Determine the exact area of a circle with a diameter of 19. Now, and then they want us to round this. So, but they still want the exact area. So we know we're going to have an answer of pi. So they give me a diameter of 19, which means my radius is half of 19. So that's going to be 9.5 centimeters. So my area is pi 9.5 squared, and they want exact area. So I'm going to leave that pi. I'm going to type 9.5 squared into my calculator. I get 90.25 because they want hundredths. I'm going to leave that pi because they said exact, and it is square centimeters. All right, let's try another example here. How many times greater is the area of circle 1 than the area of circle 2? So maybe your first instinct here is to say, ooh, the radius is 18 and 6, so this must be 3 times greater because 6 times 3 is 18. Well, let's just be really careful here because area, remember, is we're squaring the unit. So it's not linear, it's not circumference, it's not feet, it's going to be square feet. So let's see if it really is 3 times greater. Let's actually find the areas and just subtract them and compare. So for circle 1, remember our area formula is pi r squared, and we saw where that came from. So we've got an area of pi 18 squared. And let's leave it in terms of pi for easier subtraction. So it's going to be 324 pi feet squared. And over here, we're going to have pi times 6 squared. Maybe you know that that's 36 pi square feet. So now if we were to determine the difference, we would subtract them like I said earlier, but we want to know how many times greater, so we're actually going to divide these or find the ratio. So circle 1 to circle 2 is going to be 324 pi divided by 36 pi. Just like you may have done here, 18 divided by 6 gave you 3. And the pi's cancel. Type 324 divided by 36, you get 9. It's 9. The area is 9 times greater. Well, what do you notice about that? We thought it might be 3, but area is squared. What's 3 squared? It's 9. Interesting. Maybe there's something to that there. Go ahead and give these 3 a try. Press play when you're ready to see the solution. And there we go. So now let's do a couple of examples. We have 3 more examples to go. So the circumference of a circle is given, but now they want the area. All right, so now they want us to relate circumference and area. So we know that circumference is the diameter times pi, or 2 pi r, and we know that the area is pi r squared. So they give us the circumference, but they want the area. Well, we need, for area, we need the radius. How could we get the radius? Well, let's use the formula for circumference that involves the radius because we want a radius. So now let's just look at this. Instead of C, I actually know that C is 271.74. And I could divide then both sides by 2 pi. If we kind of think of this as an equation. And then I'll get my radius value. When we do that, we get approximately 43.27. Now, I'm not done. They want the area, but now I have my radius. I can say, and this is meters, area is equal to pi times 43.27 squared. So my area, they want approximately, and let's just use, they want 3.14. So we get approximately 5879 square meters. Go ahead and give this one a try. Press play when you're ready to see the solution. There we go. Example 5, we're going to apply. So a large running track is constructed to have straight sections and then 2 semicircular sections. So these sections here are semicircles. And then this section here, these are the straight sections here, okay? Assume that the runners always run on the inside line, so they're running on the inside line of their lane, and a race consists of 1 full counterclockwise revolution around the track plus an extra portion of straight segment to end up at the finish line shown. 1 full counterclockwise, so they're going in this direction. What should be the distance x between the 2 starting blocks in order to make the race fair? So we basically want to see what's the difference around the distance in the track. So what's the difference if you're in this lane and you're moving this way, and what's the difference if you're in this lane and you're moving this way? So they said the inside track is what's being used, and because of the direction they're going, this is the inside track for 1, and then this is the inside track for 2. So let's see what that means. So let's look at lane 1. What is their full distance around the track? Well, we know that these are 100-meter sections that they're going to have to do. So we know it's going to be 100 plus 100. And then we know that it's going to be, this is a half of the circle, and this is the other half of the circle, and we're talking about the distance around, so we're going to have 2 pi. We just don't know the radius. But if they're on the inside track, then their radius is 40, 2 pi 40. So the inside lane is going the distance of 200 plus 800 pi. And lane 2 has those same straight segments, and then their radius, because they go to the inside of that, their radius is 45. So it's 200 plus, I said 800, but that is 90 pi. So what's the difference between these two? Well, the difference, the 200s are the same, so the difference here is 10 pi. So that's the distance that it needs to be. And that's about, if you were to multiply that by 10 times 3.14 is about 31 feet. So that is the distance they should make it to make up for the difference. And we will come back to do example 6 and our final U tries.